Alright students, question number 2 of the functional equation I am going to discuss today. The question says like this: if fx into f bracket 1 by x is equal to fx plus f1 by x, where fx is a polynomial of degree n, then prove that fx is equal to plus minus x to the power n plus 1. This is what we have to prove. So let us see the proof of this one. It goes like this. Let us consider fx, because it is given that fx is a polynomial function of degree n. So let us consider fx as equal to a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus a3 x to the power n minus 3 plus dot dot dot, and the last term let me write as a n x to the power 0, that will be equal to 1. I am not writing that. Then prior to this, the previous term will be a n minus 1 and x to the power 1 plus a n minus 2 x to the power 2 plus a n minus 3 x to the power 3, and so on, dot dot dot. Means it is continued from here and ends at this point. Means fx is equal to this. Now f bracket 1 by x is nothing but, in place of this x to the power n, x to the power n minus 1, x to the power n minus 3, and so on, you have to take 1 by x. So this will become, means f bracket 1 by x will become a0 divided by x to the power n plus a1 divided by x to the power n minus 1 plus a2 divided by x to the power n minus 2 plus a3 x to the power n minus 3 plus dot dot dot, and it continues, and this term will turn into a n minus 3 divided by x cube plus this term will be written as a n minus 2 x to the power 2 plus this term will be a n minus 1 divided by x, and a n will remain as it is. I hope you all have understood. Okay. Now let us come back to the equation given, means this functional equation which is given to us. We start with that. So we have fx into f bracket 1 by x is equal to fx plus f bracket 1 by x. Using this and using this fx and this f bracket 1 by x, we have to prove that fx is equal to plus minus x to the power n plus 1. This we have to prove. This we have to find. Now the strategy for solving this particular problem is to get the coefficients of x to the power n in the left hand side and coefficient of x to the power n in the right hand side. Similarly, coefficient of x to the power n minus 1 in the left side and in the right side, coefficient of x to the power n minus 2 left side and in right side, one by one. So we start with the coefficient of x to the power n. So what we are going to do is this, comparing the coefficients of x to the power n in LHS and RHS of equation 1. We are taking this as equation number 1. So you see, in the left hand side we have the product. So x to the power n as in the product of this whole quantity, that is this one, and this quantity, that is this one, could be obtained x to the power n by multiplying this particular term and this one. Alright, so in the left hand side we are left with x to the power n coefficient as a0 an. Now coming to the right hand side. In the right hand side only the summation, only the sum of this particular term, and this will be written, and in that one x to the power n will appear only in this one. So in the right hand side the coefficient of x to the power n could be only a0. I hope you all have understood. From this particular equation we can get a0 bracket a n minus 1 equal to 0. So it implies a0 is equal to 0 or a n minus 1 equal to 0. Now a0 is equal to 0 is not possible. Why? Because if a0 becomes 0, this one, then this whole quantity will turn into 0. And if it is becoming 0, then do you find the fx will be converted into a polynomial function of degree n minus 1. But it is given that fx is a polynomial function of degree n. Alright, so this is not possible. a0 is equal to 0 is not possible. So only possibility is an minus 1 equal to 0. From that we can write an is equal to 1. So this is one of the result which we have got. Now in the same manner let us compare the coefficient of x to the power n minus 1. So again writing, comparing the coefficients of x to the power n minus 1 in LHS and RHS of 1, we get what? Now you see, if you are multiplying fx and f bracket 1 by x, and we have to get the coefficient of x to the power n minus 1. So do you find, if we multiply this particular term with this one, then we will be getting x to the power n minus 1. So first coefficient could be in the left hand side a1 an. Again you see, if we are multiplying this a0 x to the power n and a n minus 1 divided by x in the left hand side, that is this one, then x to the power 1 goes up, x to the power minus 1 it becomes, and this x to the power n, then multiplication of these two will give you x to the power n minus 1. So in the left hand side the coefficient of x to the power n minus 1 could be a0 into a n minus 1 beside this one. So plus a0 a n minus 1. So I think only these two possibilities are there to get x to the power n minus 1. So that is happening in the left hand side of this. Coming to the right hand side, you are finding that this particular function will not yield into x to the power n minus 1. So only possibility to get the x to the power n in the right hand side is from this fx. And in this fx, only term which contains x to the power n minus 1 is this. And the coefficient of x to the power n minus 1 is a1. So let us write in the right hand side a1. I hope you all have understood till this point. Now we have already calculated an is equal to 1. So if we are putting this an is equal to 1, what we are getting is a1 plus a0 and an minus 1 is equal to a1. Alright. So these two a1 are getting cancelled and we are left with a0 an minus 1 is equal to 0. So either a0 is equal to 0 or an minus 1 equal to 0. But a0 cannot be 0, as I have already explained you, not possible. So only possibility to make this equation valid is an minus 1 is equal to 0. So this one is the another result. What we have obtained over here is an is equal to 1. Now an minus 1, a subscript n minus 1 is equal to 0. Now next, let us we compare the same way. We have started from x to the power n, compared the coefficients on LHS and RHS. Then we have started with x to the power n minus 1, compared the coefficients of in LHS and RHS. Now x to the power n minus 2, let us we compare the coefficients in both the sides. So again we write comparing the coefficients of x to the power n minus 2 in LHS and RHS of equation 1 we get. Alright, means now we are going to compare the coefficients of x to the power n minus 2. So are you finding in this one, that is when we are multiplying fx and f bracket 1 by x to the power n minus 2 appears over here, and an, these two terms when multiplied will give you x to the power n minus 2. So the first coefficient of x to the power n minus 2 will be a2 an. So let me write that, a2 an plus, now let us we go little back, means come to this a1 x to the power n minus 1, and if a1 x to the power n minus 1 and this one, that is an minus 1 and x to the power 1 multiplied, then it will give us x to the power n minus 2, and the coefficient would be a1 into an minus 1. So that also will be added, a1 an minus 1 plus one more term will give us x to the power n minus 2, and that is nothing but this one, means a0 x to the power n multiplied to an minus 2 divided by x square. If you are multiplying these two, do you find you can get x to the power n minus 2? So the coefficient in this case will be a0 into an minus 2. So let us we write a0 an minus 2 equal to this one. This happens in the left hand side, that is in this side. In the right hand side there is only one term which contains x to the power n minus 2, and that is this one. So in the right hand side let us we write a2 simply. No other term will give you x to the power n minus 2. Now let us we put the values one by one. An we have already calculated as 1. So over here what is left, a2 into 1 will give you a2. An minus 1 already we have calculated here as equal to 0. So 0 multiplied by this a1 will give you 0. So no need of writing that. Okay, I have written it. Then coming to this a0 an minus 2 is left is equal to a2. So are you finding these two are getting cancelled, and we are left with a0 an minus 2 equal to 0. Again we have come back to the same situation as we have got in the previous one, that the product of these two is equal to 0, and this a0 cannot be equal to 0, not possible. I have explained already. So only possibility is an minus 2 equal to 0. So this is another result we have got. Now one more, lastly let us find out same thing, that is comparing the coefficients of x to the power n minus 3 in LHS and RHS of equation 1. We get, okay, let us see, we have to get x to the power n minus 3, I suppose. Yeah, x to the power n minus 3 we are finding is present over here. That if we multiply to a subscript n, then we will be getting x to the power n minus 3 and the coefficient will be a3 an. So first coefficient is a3 an plus. Now to get x to the power n minus 3, if we are multiplying this particular term, that is a2 x to the power n minus 2, and over here a n minus 1 x, will you get x to the power n minus 3. So the coefficient in this case will be a2 into a n minus 1. So let us write that a2 a n minus 1 plus, next we have a1 x to the power n minus 1, that if we multiply to this one, this particular term, a n minus 2 divided by x to the power 2, do you find, you will get x to the power n minus 3, and the coefficient will be a1, this one is a1, and a n minus 2. So finally it is a1 a n minus 2. One more term will give you x to the power n minus 3, and that is this one and this. In the denominator you have x to the power 3, that will go in the numerator, and x to the power n minus 3 we will be getting, and the coefficient will be what, a0 a n minus 3 a plus a0 a n minus 3. This happens in the left hand side, that is we are talking about this one. In the left hand side these coefficients will be obtained, and in the right hand side are you finding there is no chance of getting x to the power n minus 3 in this one. So only possibility to get x to the power n minus 3 is in fx, and in fx x to the power n minus 3 is obtained only in a3, that is coefficient. So in the right hand side we have a3. Alright, now you see a n minus 2 was equal to 0. So are you finding this particular term will turn into 0. Again a n minus 1 we had as 0. So this term also will become 0. Again a n we had, try to recall, a n was equal to 1. So if we are putting a n as equal to 1, then we are getting this term as a3, and only this term will be left, a0 a n minus 3 is equal to a3. So are you finding these two are getting cancelled, and we are left with a0 a n minus 3 is equal to 0. Once again this one equal to 0 is not possible. So only possibility that this a n minus 3 equal to 0 means this whole equation is equal to 0. In that one the possibility is a n minus 3 is equal to 0. So one more result we have got, that is a n minus 3 equal to 0. So like that if you keep on finding, then up till means a we have started from, okay, let me just write one by one. A n was equal to, a n is equal to 1, and after that a n minus 1, starting from there a n minus 1 a n minus 2, a n minus 3, dot dot dot. We are finding that the subscript value is keeps on reducing. So ultimately, do you think we will get a1, and prior to that a2, prior to that a3, and so on? And all these terms we have proved equal to 0. We can prove this also equal to 0. So all these terms will become 0. Alright. Now we are left with to find out the value of a0, that is this one. This we have not yet obtained. Yeah, we have not yet got the value of a0. So are you finding, to get the value of a0, if we are multiplying fx and f bracket 1 by x, and if we are multiplying this term with this x to the power n, this x to the power n will get cancelled, and we are left with a0 square. Similarly, if you are multiplying this particular term to this one, then it will give us a1 square, as because this x to the power n minus 1 and x to the power n minus 1 will get cancelled. Same way, if we are multiplying this particular term to this one, then we will be getting a2 square, and x to the power n minus 2, x to the power n minus 2 will get cancelled, and so on. So what we are getting is, are you finding the coefficient in the, so let me just write, comparing the constant terms in LHS and RHS of equation 1, we get a0 square plus a1 square plus a2 square plus dot 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 a n square plus a n minus 1 square plus a n minus 2 square. This happens in the left hand side. Now let us see in the right hand side what is happening. Means if we are adding fx and f bracket 1 by x, alright, only the constant terms, not all the terms, then do you find the constant term in this fx is this, and constant term in f bracket 1 by x is this? So if these two terms are added, do you think you will be getting an, that is 2an we are getting? I hope you all have understood. Now let us see the values of this. Alright, all these terms, do you find we have proved equal to 0? And an we have already obtained as 1, so 1 square it becomes. Dot dot dot, and a0 square we have to find out. In the right hand side, do you find it is 2 multiplied by 1? So ultimately what we are getting is a0 square is equal to 2 minus 1, that is 1. So finally what we are left with, a0 is equal to plus minus 1. So we have found the value of a0 as plus minus 1. Let us come back. What we have to find? We have to prove that fx is equal to plus minus x to the power n plus 1. And we have assumed fx is equal to a0 x to the power n plus a1 x to the power this, all these terms. So let me just write again. Means your fx was equal to a1 x to the power n plus a2 x to the power n minus 1. What next? No, I think there is some mistake over here. a0, we have to start from a0, sorry, a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus dot dot dot, and ultimately we had a n, and prior to that a n minus 1 x and so on, and all these terms means a1 a2 up to an, all these were 0, so all these terms will become 0, and a0 we have just now calculated as plus minus 1. So what fx is plus minus 1 multiplied by x to the power n will give you x to the power n, and an was calculated earlier as 1. So are you finding we have got the result? I hope you all have understood. Thank you.